Alright, welcome everyone. My name is Kevin Lipwood and this is another video for our series of training materials for Theagen's Terra workflows for SARS-CoV-2 genomic analysis. Today's video is a continuation of our tutorial walkthrough for prepping samples for submission to GenBank and GISAID using the Mercury workflow series. If you haven't watched part 1 of this tutorial, I highly encourage you to do so, as we will be working with the results from that video as inputs to the workflow in today's video. A link to part 1 of this tutorial is available in the description below. Alright, so with that, let's jump into it. Okay, so in this video, we'll be walking through part 2 of this 2-part tutorial. In our last video, I showed you all how to use the metadata table formatter to upload sample metadata to your Terra workspace. And then we prepared GISAID and GenBank files for samples individually using the Mercury single-end prep workflow. And so today, we'll continue working with that same Clear Labs dataset to cover how to use the Mercury batch workflow to combine the prepared assemblies and metadata files for batch upload. Then I'll go over my process for getting the Mercury output into the required GISAID template for batch submission onto their platform. All right, so with that little intro, let's get into Terra and hop into it. Okay, so here are the 10 Clear Lab samples that we ran through the Mercury single-end prep workflow in part 1. And here you can see that 8 of these samples have assembly and metadata files that have been prepared for GISAID and GenBank submission. And if you watched my last video, you'll remember that 2 of these files don't have any of these prepared files, since they contain such a high number of ambiguous bases in the final consensus assembly. And you can see that here with the number of ends in each sample. Okay, so in this video, I want to show you how we can combine the outputs for these 8 samples here to create a single assembly and metadata file for both GenBank and GISAID. So 4 files altogether. One concatenated FASTA file for GenBank that contains all of these assemblies, one combined metadata file for GenBank for all of these samples, and then the same thing for GISAID. One concatenated assembly file containing all 8 of these assemblies, and one combined metadata file for all 8 of these metadata sheets. But before we do that, I want to go over the differences between the sample data tables that we've been working with and the set data tables that you see here on the right. So for every Terra workflow that we've run so far in this training series, we've only ever been working with a sample data table. And in this table, you can see that every row represents a single sample, and that every column represents some attribute associated with these individual samples. But if you've been following along, you may have also noticed another data table with the same name here on the left with an underscore set. So the main data table we've been working with here is called Clear Lab Specimen. But then there's a Clear Lab Specimen set data table as well. Well, if we click here, let's see what's going on. So with these set data tables, each row can represent a collection of samples rather than just one. So you can see here in this first row, there's actually 10 Clear Lab samples being described. So this row is describing this collection of 10 Clear Lab samples. And if you look at the IDs here, you can see that each row describes a past workflow job that I've submitted with samples from the original sample data table. And all of these Clear Lab Specimen set rows have been created automatically. So when I run any workflow, this set table will get populated with the name of that job with this date and timestamp, and then a second column describing the collection of samples associated with that job. And you can see with these workflows at the set level, there's no other output to be found. That's because for these 2 workflows, this Mercury single-end prep and Titan Clear Labs, we define the input root entity type to be the Clear Lab Specimen sample data table. So if we go back here, all of the outputs for those 2 workflows are populated in this table. But for workflows such as Mercury Batch, where we want outputs for a collection of samples, we want to make sure that when we define the root entity type, we select the set data table rather than just the sample data table. Okay, so I know that was a lot of rambling of data tables and sets and samples. So if that didn't quite click, I think things will clear up as we hop into the Mercury Batch workflow itself. Just know that since we're working to generate output for a collection of samples rather than just individual samples, we want to be working at the set level. Okay, so let's get into things from there. So as with every workflow, we'll follow the same basic 3 steps. First, we're going to select the appropriate workflow. Then we're going to define the inputs and outputs for that workflow. And then we're just going to hit run analysis. And in this case, as we define the inputs and outputs for the Mercury batch workflow, we'll be sure to define the inputs and outputs at the set level. Okay, so let's first start by selecting the appropriate workflow. I'm going to go ahead and navigate up here to workflows. And you can see here that I already have the Mercury batch workflow available, so I'm going to go ahead and select that. All right, then I'm going to go ahead and select the latest version that I have available, and for me that is 1.3.2. All right, so now I'm going to start defining the inputs and outputs for this workflow. So let's first select the root entity type. And since we're working with those same ClearLab samples, we want to pick a ClearLab specimen data table. But since we're analyzing a collection of samples, we want to make sure that we select the ClearLab specimen set. Okay, great. And when we select a set, we have to be explicit about which samples we want to analyze. So to pick that, we'll go here to select data. And from here, I want to go to create a new set from selected ClearLab specimens. And so here are all of our samples. Okay, so remember that with Mercury Batch, I'm running this workflow to combine submission files from multiple samples. So as I select samples to analyze, I need to make sure that I select samples that have outputs to batch. So for example, if I just click this left box here and select every sample, I'm going to be including sample 5, a sample that does not have any submission files based on the quality of the consensus genome. And when Mercury Batch tries to include this sample to the final output, it's going to error out since there are no files for this sample to batch. So I need to make sure that I only select samples that have the proper files as inputs to the Mercury Batch workflow. And rather than scrolling through and selecting or deselecting one by one, I can go up here to this GenBank assembly and click it to sort and deselect the files that don't have these required inputs. Also, if, for example, I don't want to batch the entire dataset and only need to batch up samples associated with run 1 or run 2, I can again use this search bar to filter for only those samples and then select the appropriate input from there. This is particularly useful when the dataset grows and there are already samples that I've submitted to GenBank or GISAID, and I only want to work with samples from runs that I have not yet batched. Okay, but for this example, we want to take every sample with a submission file. Oh, and be careful here when working with datasets larger than 25 samples, since this left checkbox here only selects the samples that are viewable on a page. So you may miss some samples and need to extend your selection to the second or third page when working with larger datasets. But for us, this is everything that we need, so we'll go ahead and hit OK here. Okay, so now that I've selected which samples to analyze, I need to further define which elements of those samples that should be fed in as inputs to the Mercury Batch workflow. And this works a little bit differently when working at the set level. Since our root entity is a set, when we start using that this dot notation, the this represents the set we've selected. So for example, for this input of our GenBank fast A's, you may think based on what we've done in the past, I could write this.GenBank assembly. And you'd be right if the root entity was the ClearLab specimen sample table. But since we're working at the set level, we have to be a bit more specific. So for this input, we actually have to write this.ClearLab specimens.GenBank assembly. So this is saying that within this being the ClearLab specimen set, there is a column of ClearLab specimens, and that for every ClearLab specimen, they have an element called GenBank assembly, and this is what we want to describe as input for this workflow. And then that's the same thing for every other input for this workflow. So let's go ahead and fill that out. And remember, we're inputting the number of Vader alerts to this workflow so that Mercury Batch will exclude samples with raised Vader alerts in an effort to expedite the sharing of hassle-free submissions. And you can change this Vader alert threshold by providing an optional input here, but we'll keep this at default for this tutorial. Alright, so now that we have all the inputs defined, I'm going to go over here to Outputs. And for this, as pretty much every workflow, I'm just going to go ahead and select Use Defaults and allow it to populate the default outputs. And then with that, I'm going to go ahead and hit Save and run analysis. And so that run actually failed, but that's all right. This kind of thing does happen. And so maybe I can show you how I troubleshoot an issue like this to get things going again. So if I click on this little speedometer here, it will bring me to the workflow dashboard. And from there, I can see which task in the Mercury Batch workflow actually failed. So let's go ahead and click this. Okay, so in taking a look at this screen here, I can see that the GISAID compile step failed. So the step that tried to batch all of the GISAID assembly and metadata files never ran to completion. But if we go up here to the GenBank compile task, we can see that this one passed without an issue. And so when I see something like this, I immediately assume that I must have entered something wrong when defining the GISAID inputs for the Mercury Batch workflow. So if we go back up here to the submission itself, and then click here, we can see how we configured those inputs and outputs. Okay, and taking a look at these input attributes. Okay, I see the issue. So for the metadata field, you can see I'm missing that A in GISAID_metadata. So when this ran, Terra was looking for a column called GISAID metadata to compile. But of course, this doesn't exist, so this resulted in the run failure. Okay, so that's an easy fix. So let me just click and add an A here, and that should set things straight. Oh, and I need to reselect the samples to analyze. So I'm going to go up here to select data. And I could go up here to create a new set from selected specimen in the same way that I did before. But remember that every time I launch a job, the set is automatically created. So rather than creating yet another set to work from, I can work from the set that was already created for that failed job. So I can click here to this Mercury Batch set that already contains the 8 samples of interest. All right, so then I'm going to hit OK. Then I'm going to save this and hit Run Analysis. All right, let's cross our fingers this time that this runs to completion. All right, success. So this time things ran to completion after correcting that little typo. So now let's go back to the data to see these outputs. So I'm going to go back up here to data. And then we should be able to see the outputs here in this Clear Lab specimen set data table. Okay, and you can see here on this row, here is all of the Mercury Batch output. So the output here includes the 4 files for submission that I mentioned at the top of this video, the concatenated assemblies for both GISAID and GenBank, and the compiled metadata sheets for the 2 repositories as well. Also in the outputs are TSV files that capture which samples have been batched and which samples were excluded based on their Vader alerts. And this can be really helpful for record keeping moving forward. But the most relevant files are the upload FASTA and upload metadata sheets for each repository. And for GenBank, these 2 files should be completely compatible for GenBank upload. And that's also true for the GISAID upload FASTA file, but for the metadata file, this needs to be inserted into the GISAID metadata template. GISAID is very specific about this, so I'm going to show you my approach to get this workflow output into that template file. Okay, so first, for those of you who are not familiar with this template, GISAID makes this available from their batch upload page, and you can just download this here. And so I already have that downloaded, so let me just pull that up here. Okay, so here is the GISAID metadata template. And so what we need to do is get the GISAID upload metadata content that was generated with the Mercury Batch workflow into this template sheet, specifically here on this second sheet. But be careful when doing this. Intuitively, you may think you could just download and open up the workflow output and then copy and paste it into this sheet. But because Excel is Excel, it will auto reformat your dates and mess with the entire upload process if you just open up the sheet as is. So let me show you my little workaround to this whole thing. Okay, so here is the GISAID upload metadata file that Mercury batch generated. So I'm going to go ahead and download this file by clicking it and hit download. Okay, great. So now you can see it on my environment here in my desktop. So to open it, I'm actually going to right click it and go to open with. And by default, it's going to try and open it with Excel. But again, this will lead to date reformatting chaos. So instead, I'm going to open it with a basic text editor. On Macs, like my machine, this can be something like Text Edit. If you're working on a Windows machine, you should be able to open this with a program such as Notepad or Notepad++. But since I'm working on a Mac, I'm going to go ahead and open this in Text Edit. Okay, so now it's available to me in this text editor. I'm going to go ahead and select all with Control A and copy everything with Control C. And then I'm going to go back to the GISAID metadata template file. Okay, so from here, I'm going to go to the submission sheet, that second sheet, and I'm going to make sure that I click that A1 cell. Okay, then from here, I'm going to go to this paste drop-down menu, and I'm going to use the text import wizard. Then I'm going to make sure that the delimited box is checked, and I'm going to go hit next. Okay, and then I'm going to make sure that comma is the only delimiter selected. So I'm going to go ahead and check comma and uncheck space. Great, then I can go ahead next. And then from this page, I'm going to go ahead and scroll over to the collection date column, click that. And instead of general, I need to make sure that this is imported as text. All right, from there, I can go ahead and hit finish. And then I'm going to hit OK. Okay, great. Now you can see that we have the appropriate metadata inserted into this GISAID metadata template with the date properly formatted. So once I save this, then I can upload it directly to this GISAID page here. All right, and I know that was a bit quirky and kind of a funny workaround using Excel, but I assure you this will get the job done. And after just a few runs and repetitions, I'm sure that it will come more easily for you. So that's it for now. I hope that this was clear for everyone and that you were all able to learn a little bit from this video. Again, if you have any questions, please feel free to leave them in the comments below, and we will be sure to clarify as much as we can. Thank you, and I will see you in the next one.